Microtubules are dynamic cytoskeletal polymers essential for all cells. They are made of the protein tubulin, an alpha-beta heterodimer that self-assembles head-to-head, making protofilaments, which themselves associate laterally, making a cylindrical wall. Tubulin binds the small molecule GTP, or guanosine triphosphate. During microtubule polymerization, this molecule is hydrolyzed to GDP, or guanosine diphosphate. The GDP-bound form of tubulin is unstable in the microtubule and gives rise to the phenomenon of microtubule dynamic instability, by which microtubules switch between growing and shrinking phases. When microtubules lose a critical layer of GTP-containing tubulin subunits, shown in brown, they depolymerize by peeling and curving of the protofilaments. Although protofilament peels are short-lived, we stabilize them for structural analysis to define the tubulin arrangement and conformation within them. These disassembly intermediates break down into smaller pieces. We found that in the GDP depolymerized form, the tubulin dimer makes bent contacts but is also bent itself with a 12-degree angle. Upon GDP exchange for GTP, the tubulin subunit straightens, allowing it now to repolymerize, making both longitudinal and lateral interactions. The resulting assembly intermediate is an open sheet that is very short-lived, but we were able to stabilize into helical ribbons that were amenable to structural studies by electron microscopy and image analysis. This polymer shows the protofilaments arranged in pairs, with contacts that alternate between those found in the cylindrical microtubule and new contacts never described before. The arrangement is said to be able to roll into a tube when it reaches the right width and length. The closing up of the microtubule is a highly cooperative zipping up process. Thus, microtubule growth occurs by sequential sheet extension followed by microtubule closure. Driven by the hydrolysis of GTP, microtubules switch between growing and shrinking phases via the structural intermediates just described, giving rise to a very dynamic cellular cytoskeleton that performs essential functions in the cell, from transport of cellular organelles to division of the genetic material between daughter cells during cell division. Microtubules are fascinating nanodevices that have evolved to undergo amazingly complex assembly processes.